This is the summary created from the video. Lecture 47, Containers, Container-Based Virtualization, Kubernetes Docker Container. The video explores DC microgrids, which avoid multiple AC-DC-AC conversions, reducing losses. DC microgrids often operate in isolated mode without a main grid connection, and can also be interconnected for optimal operation. A standalone DC microgrid system comprises renewable sources like PV and wind, batteries, supercapacitors, and diesel generators. It caters to critical loads while managing non-critical loads, with sources interfaced through converters for bidirectional power flow. The control algorithm optimizes resource utilization based on load versus generation in a standalone DC microgrid. It charges the battery when generation exceeds load, discharges the battery or activates the diesel generator when generation is lower, and prioritizes critical loads when battery state is low. Simulations analyze renewable power generation in relation to battery state load and diesel generator activation in a standalone DC microgrid, contrasting scenarios where generation is higher or lower than load. DC microgrids operating at different voltages can be interconnected using DC-DC converters, increasing energy security, renewable utilization, and supply quality while reducing costs. Excess renewable energy from one microgrid can meet the load in another. The interconnected system consists of two autonomous DC microgrids separated by cable length, each with PV sources, battery storage, converters, and a dual active bridge converter for bidirectional power flow. The control strategy covers overloading, underload charging, and discharging scenarios in interconnected autonomous DC microgrids, with independent control loops for battery, PV, and load shedding in each microgrid. Simulations showcase two interconnected microgrids at 380V and 48V with varying PV capacities, battery sizes, and fixed and variable loads, exchanging power without violating voltage requirements. The control effectively manages source storage and using bus signaling, enabling autonomous operation and reliable power sharing between microgrids, improving system reliability. The analysis focuses on isolated DC microgrids and their interconnection, enabling efficient renewable energy utilization, optimized resource use, storage management, and load management through control algorithms. Simulations validate the feasibility of interconnecting DC microgrids at different voltages, allowing power exchange and providing mutual benefits through increased reliability and utilization. Please stay tuned for more summary videos.